I'm a software engineer in one of the FAANG companies, and today this is my first YouTube video that I'm uploading, and hope this will help you somewhere during your interviews. So by that thought, let's start off this with this question: contains duplicate. It is a question that is asked in a lot of companies, and it is a good question to get and hold on because a interviewer can know a lot about you, about your problem solving skills through such simple questions which look simple, but if we just try it's all about our explanation, how we explain it to the interviewer. So how we are going to approach this question, how I'm going to show it, is something that you should follow in an interview as well. If an interviewer asks you this question, our aim should not be just to give them the most optimized solution. No, our aim should be to give them a very brute force approach at once and slowly build it up. Slowly try to optimize it until you reach an optimized solution and then code it up. So if you follow this route, if you try from the very brute force approach and then try to go to the very top, the recruiter can sync up, and they can learn a lot about your thought process, about your problem solving skills. And if this is how you approach a problem, you will definitely be able to crack the interviews. Okay, so let's talk about this question. So in this question, what we need to find out, is there a way we can see if there are any duplicate values inside an array? Okay, so this is the question. So as you can see in this example, there is 1 1, there are duplicates, so we will return true. In this array we can see there is no duplicate, so we will return false. In this we can see there are multiple duplicates, so we will return true. We just want one duplicate, we do not care if there are multiple duplicates or not. Okay, so what is the brute force approach that is coming to our mind? I guess we all might be thinking of, how about we just take one value at a time, search in rest of the array, search in rest of the array. If we are able to find that value, if we are, we will return true, else we will continue. So let's take 1 and we will search in rest of the array. We will say that is this equal to 1, is this equal to 1, is this equal to 1. So there will be a point where we will find a match. If we find a match, we will return true, else we will continue. Okay, so we can see over here, we had 1 with us, we are searching, do 1 exist, are you equal to 1, are you equal to 1? No, none of them gave us a true. So we will continue with the second index, that is true, and we will search in rest of the array, that are you equal to 2, are you equal to 2, and so on. We will go with the next index and we will search in rest of the arrays if any of the value is equal to our index value. So this is the approach. If we are able to find a match, we will return true, else we will go with false. So let's talk about the time complexity for this brute force approach. So this was a very brute force approach, and as we can see, we are taking one index at a time and we are traversing the entire array, the entire rest of the array. So it's like for each value we are traversing the rest of the array. So in the worst case, we can say that for each value we are going for all the rest of the values, for all the values. So it will be n cross n. Each index value will have one more for loop within it, which will be traversing for the rest of the array. So the time complexity will be n square. Okay, so this was a brute force approach. Let's see if there is any better approach. So we can see that what we sort this up. If we sort this array, let me show you what will be the output. This is my current array. If I sort it up, it will be 1 cross 1 comma 2 comma 3. This will be the sorting array. After we are done with the sorting. Okay, we can see that for each index we can check from I, if we consider I is equal to 1, for each index we can consider that is this equal to the past value, is value at I equal to value at I minus 1. If it is equal to this, we will return true, else we will continue. So you can see I checked that is my I is equal to I minus 1, and it gave us true, and we directly returned true. Else we would have continued to the entire array and we are searching that is this value equal to the previous value, is this value equal to the previous value, and we will go on until we find a match. And if at the end of the day we are able to go till the very end of the array and still we have not gotten any true, that means it's a false. We are not able to find any duplicate. There was no value which matches with its previous value. So let's quickly take this example as well. So in here we can see that if we sort it up, we will see that is this equal to its previous value. It will say true. Yes, it is equal to true. It is equal to its previous value, so we will return true. So this is our second approach. So let's quickly talk about the time complexity for this question. So as I told you, we will be sorting the array and then we will be traversing the entire array. Okay. And during traversing, what we will see if my value at I is equal to value at I minus 1. If it is equal to this, then we will return true, else we will return false. Okay, so this will be our approach. Let's talk about the time complexity. The sorting itself takes a lot of time, that is n log n, and on top of that we will be traversing again, so it will be an additional O of n. So overall the time complexity will be n log n plus n. Fine. Can we do better than this? We have given them an approach, a brute force approach that takes of n square. We have given them an approach of sorting and traversing that is of n log n plus n. Can we come up with a better solution? Yes, we can. So one data structure that is coming to my mind when it comes to finding out the duplicate values are hash sets. That will be our third approach, to use a hash set. So let me first tell you what's the specialty of hash set. Hash sets are known to have just unique values. They are known to behave in such a way that if we are pushing multiple values in it, if we are pushing 3 a lot of times, let's suppose 10 times I'm pushing 3, 3, 3, 3, 3, but hash set have the property which will consider that 3 just once. So this is how hash set works. So I'm saying, why not use a hash set? Although by using a hash set, your space complexity will increase to O of n, but in terms of time complexity, we will see a huge difference. Let's see what is it. So our space complexity will be O of n, but how can we use a hash set? We will see that we will insert 1. We will check the value at index 1. That is 1. We will check, is it already there in our hash set? It will say no, it is not. So we will add this value to our hash set, saying that no, this is the first time that we are encountering 1. Fine. We'll go to the next value, that is 2. I'll say, can we insert 2 in it? We'll say yes, we can insert 2 in it because 2 is not already present. Fine. We'll go to 3. We will again check, does our hash set already contains 3? If it does not, that means we are encountering it for the first time, and we will insert 3 inside a hash set. The moment we got to 1, we will see that this value already exists in our set. That means we have already encountered in the past, and this is the time where we just realize that we have found a duplicate, and we will return true. Else we will just return false. If we are at the end of the day, if I am able to put all the values inside my hash set without finding any duplicates, I'll return false. So this is how we can use hash set. Let's talk about the time complexity. As you can see that we just traversed this array once. That's it. We did nothing else. We just traversed the array. We are checking at each index, is that value already present in our hash set? If it is present, then we will return true. Else at the end of the day, we will return false. So this is the most optimized solution where we are getting a time complexity of O of n, which is very good. So this is how you should go and present your question to an interviewer, that let's go with a brute force approach. Maybe we can optimize it by sorting it. And how about we use some good data structures so that this can be very, very optimized. So these are the ways we can represent this question, and these are the steps that we should follow. Let me quickly code this up with the most optimized solution. So as we discussed that we will be using a hash set. So let's first declare a hash set. So let me declare a hash set that will be of integer type. All right. So we just discussed that we will be traversing over the entire nums array, and we will check whether that value is present in our set or not. So let me quickly traverse first, and for that I'll use a for loop, and Now let's check, does this value already exist in a set or not. So I'll see if my set contains num, that means do we already have that value. If we have, we'll just quickly return true. That's it. We will not think twice. If we got a value which is already present in a set, that means that there is a duplicacy, and we will return true. Else what we will do, we'll add this new value that we have just encountered inside my set. Fine. At the end of the day, if I am able to come out of this for loop, that means this condition was never true. That means we were never able to find a duplicate value. That is, if there is a duplicate value at any point we encountered a duplicate value, this will return us true. We will not go forward. We will directly return true the moment we find this value. Fine. But if we are coming out of this loop, that means we were never able to satisfy this condition. We will return false at this point. So this is the approach. Let me quickly run this up. Yes, we are able to run it. So as you can see, we use a hash set. We are checking if that value is present in our set or not. If it is not at the end, if it is not present inside our set, if none of the values are repetitive, we'll return false. Let me quickly submit it up. Yep, that's it. You can see that it's a very good solution. The runtime itself is very nice, and the space complexity is also not that bad. I would say it's a very good solution, good optimized solution. And that's it. This will be the end of the video. Let me know if there are any feedbacks, if there are any learnings that I can share from my interview experiences. And I generally code in Java. Let me know if you have any question or any feedback on that as well. So that's it. I will come up with some more good questions that are generally asked in interviews. So till then, thank you so much.